Hello guys, welcome again to the show of Massive Quality Mathematics. Today I want to show you how to find the inverse of a matrix. So I want to do this example with you. Let D be 3 by 3 matrix 1 1 1 1 2 3 1 3 6. Then the question says find the inverse of D using the Gauss-Jordan elimination. You know that when you use a Gauss-Jordan elimination, you use an elementary row operations. Firstly, you can interchange rows. You can multiply a row with a constant, and you can add a multiple of one row to another row. So you will recall that D times D inverse gives us an identity matrix. So you know that an identity matrix is a matrix with a determinant of 1, or is a matrix with ones on the main diagonal and zeros elsewhere. So you will agree with me that D times D inverse is I. So in this case, they say we need to find the D inverse. So, but you can write what we call a joint matrix. D joint with I must give us, when we apply Gauss-Jordan elimination, it must give us I D inverse. So what we're going to do in this case, we're going to use elementary row operations or to reduce this matrix D until where there's D we're going to get identity matrix, and where there's I we're going to get a matrix, and this matrix will be called, or is the inverse of that matrix. So then let's get into it. This is, what is D? It's 1 1 1 1 2 3 1 3 6, and identity matrix 1 0 0 0 1 0 0 0 1. So firstly, we're going to use elementary row operations to perform this. Now you can see that we need ones on the main diagonal here. So we can make this 1 and 1 to become 0. We can convert this 1 and 1 to be 0, 1 on the second row and 1 on the third row. So I can say that R2 equals to R2 minus 1 minus R1. R2 is equals to R2 minus R1, and R3 is equals to R3 minus R1. We need to make these two numbers zeros. So let's do that. This will be 1 1 1. So 1 minus 1 is 0. We're using this one. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 3 minus 1 is 2. Then this time around is 1 0 0. We apply the same this side. 0 minus 1, it's a negative 1. 1 minus 0, it's 1. 0 minus 0 is 0. Then even here, 1 minus 1 is 0. 3 minus 1 is 2. 6 minus 1 is 5. You apply the same here. 0 minus 1 is minus 1. 0 minus 0 is 0. 1 minus 0 is 1. So again, you find zeros here. Then we can make this 2, 0 because we need an identity matrix this side. We need an identity matrix this side. So let's make this 2 become 0. We'll focus on row 2 and row 3. So row 3 will be row 3 minus 2 row 1, because if you can say 2 minus 2 into 1 is 0. So this will be this will become 1 1 1 1 1 1 0 1 2. So this will be 0 minus 0. 0 minus 0 is 0. 2 minus 2 into 1, which is 0. Then 5 minus 2 into 2, which is 5 minus 4, which is 1. Which is 1. 1 0 0 minus 1 1 0. Then it will be minus 1 into 2, minus 1 minus 2 into minus 1, which is minus 1 plus 2, which is 1. 0 minus 2. This is R2. This is R2. So this one will be minus 1 into minus 2 into minus 1, which is 1. 0 into minus 2 into 1, which is 0 minus 2, which is minus 2, which is minus 2. Then 1 minus 2 into 0, which is 1, which is 1. This is 2. So you can see that we are going there. We are going there. Let's make this 2 0 and this 1 0. How can we perform this? We can make this R2 to become 0 by only focusing on R2 minus 2 R3 minus 2 R3, and we can make this 1 become 0 by saying R1 and focus on very same thing, R1 minus R3. So this will be, allow me to write it here. This will become let's start with this one. This is just 1 minus 0, which is 1. 1 minus 0, which is 1. 1 minus 1, which is 0. So this one will be 0 minus 0. 0 minus 2 into 0. This is 0. This one will be 1. 1 minus 2 into 0, which is 1. 2 minus 2 into 2, which is 0. Then we have 0 0 1. This side we have 1 minus 1, which is 0. 0 minus minus 2, which is 2, which is 2. 0 minus 1, which is minus 1. We have minus 1 minus 2 into 1, which is minus 3. We have 1 minus 2 into minus 2, which is 1 plus 2, which is 5. We have 0 minus 2 into 1, which is minus 2. Then we have 1 minus 2, 1. So this one will become we can say I need to make this. You can see that in order for this to be matrix, we need to convert this 1 into 0. So how can you do that? There's many ways of doing that. We can just focus on row 1 and row 2, just subtracting. So R1 will be R1 minus R2. So you can see that this one will become that minus that, will become that minus that. So will become R1 minus R2. So let's do that. This one will be 1 minus 0, which is 1. 1 minus 1, which is 0. 0 minus 0, which is 0. 0, 1, 0. Just copy them as they are. 0, 0, 1. Then here, similarly, we can say 0 minus minus 3, which is just 3. 2 minus 5, which is minus 3. Minus 1 minus minus 2, which is minus 1 plus 2, which is 1. Minus 3, 5, minus 2, 1, minus 2, 1. You can see that we fulfilled the fact that we need an identity matrix here and the inverse here. You can see that you can simply see that this matrix, this side, is an identity, is an inverse of D, since we said it before that if you can do this, then you can say this one is the inverse of D. So therefore we can say without any fear of contradiction that the inverse is the same as 3 minus 3, 1 minus 3, 5, 1 minus 2, 1. So you can verify that this matrix indeed is the inverse of D by only multiplying and check whether you will get an identity matrix or not. So that's how we can do it. That's the inverse of matrix D. You must write a joint matrix or an augmented matrix. Therefore, you convert D into an identity matrix, and that other matrix will be your inverse of D. Thank you very much for your attention. If you find this helping, you can support by subscribing, liking, and sharing my videos. I convince you to watch the video from start to an end because it's very important, and I also convince you to subscribe to support me to be somewhere. So thank you so much. If you have something, you can comment. You can also comment, there's no problem. I usually go through comments. You can comment with problems that you are facing, or with anything that is you are facing challenge, so that I can help somewhere somehow. Thank you very much.